Good morning and welcome everyone. Uh, Happy to see you all can join this morning. This is Global Precipitation Measurement Mission. It's an applications webinar series. This is webinar 4. We've had 3 previous webinars every 3 months about. And this one is a final one for this series. We're going to focus on some updates of GPM data and then work with Python to read GPM data. I want to start with acknowledging my colleagues here. First of all, Dalia Kirschbaum, she is the GPM applications lead at NASA Goddard, and she has supported this webinar series. Our Kristen Weaver coordinates everything to make these webinars happen, and Jacob Reed also helps with putting everything on the website for users to view. I especially want to thank Amanda Ramsey. She's my colleague at JSAT at UMBC, and she has worked with Python codes that are present in here. Finally, I also want to thank NASA Applied Remote Sensing Training Program. They have been doing a number of application webinars, and GPM features very highly in these webinars. So these are some of the key factors that make these webinars possible. So overall objective of this entire series was to facilitate GPM precipitation data usage, mostly for research and application and decision support activities. So that has been the idea behind this webinar series. Our previous webinars, they started from detailed overview of the mission and went through all the data products, how to access this data. And finally, last webinar, those of you who could attend, it was focused on using GPM data with QGIS, which is an open software. So how to get GPM data, download from NASA tools, and then display and analyze in QGIS. Today we are going one step further. We actually want to work with digital data. Earlier we have focused more on online analysis or download through online tools. This session should allow you to go directly to GPM FTP site, download data, and then use Python script that are provided here to start working with the data. So overall, agenda for today is that we will have a brief overview of GPM mission again for those of you who are attending for the first time. Then we will have product updates and again how to access them just very quickly. We will go through these sections. We'll say something about GPM ground validation that has been going on. And then finally, we will have steps for using Python script to read HTF file GPM. Today we are going to focus on iMerge. That's a multi-satellite product. I will talk about that in a minute. We do want to point out that the Python scripts, they were designed as a general framework to read HTF5 format files. And there's also script that Amanda has written that will provide special subsetting. So the idea is that read data in HTF file format and save them as text files so you can quickly read and rearrange for your own region or your application. So just a word of caution here is that the script, you will have to modify your own applications. This is more like a idea that this is how you use. You can use framework, this scripts, and put your own code within for your own region, for your own applications. So with that, we'll start with brief overview of GPM. And this is the site we've always talked about. This is pmmnasa.gov. There's a training section here. You will see all the previous webinars posted here. All the presentation slides are there as well as recordings are there that you can go back and visit anytime. So to start with, GPM, as most of you may know, it's a constellation program. There is a core satellite, and then there are a number of international satellites. They work together to provide global precipitation. So GPM core satellite was launched on February 27th in 2014, and you can see all other constellation satellites. TRIM no longer exists anymore, so that is not part of the constellation now, but it used to be. And even now, TRIM calibration is used for a to calibrate other satellites. So there is a TRIM product available based on multiple satellites. Um, so there are other NOAA, there are Japanese, French, Indo-French, and European agency satellites. They are part of GPM constellation. Major advantage of GPM over TRIM is that TRIM really focused on tropics, about 35 south to 35 north, and the yellow orbits are shown here, which are TRIM orbits, whereas GPM extends from 65 south to 65 north. And with the constellation satellites, pole-to-pole coverage will be possible in very near future. And so this is the advantage over TRIM. Quickly talking, there are two sensors in GPM core satellite, GMI, that is GPM microwave imager, and dual precipitation radar. Um, Both of these are microwave instruments. GMI is a passive instrument with multiple frequencies ranging from 10.6 gigahertz to about 183 gigahertz. The top two, 186 and 183, are addition to what TRIM had, and there is additional frequency in precipitation radar compared to TRIM, that is Ka frequency has been added. And because of this improvement in sensors, GPM has a higher spatial resolution, also has it measures light rain and snow more effectively. So GPM algorithms can be found here. There are basically 4 algorithms, and we have talked about these in detail in previous webinars. This is more or less just we're walking through the entire series here to recap everything. So algorithm theoretical basis documents, they have 4 algorithms. One is just for retrieving precipitation from dual precipitation radar, one from GMI, and there is a combined DPR and GMI algorithm that combines radiometer and radar. And then there is US integrated multi-satellite retrieval for GPM or iMerge. So these 4 algorithms are developed. The combined algorithm and GPROF, they all get used into iMerge. In addition, all the constellation radiometers and sounders are also used in iMerge. Here is a summary of level 2 precipitation products. And as we talked earlier, precipitation level 2 data are high resolution data. These are swath and pixel data. This is at native resolution. So there are sensor-based products available from DPR, one frequency KU alone, KA only, and combined KU and KA. GMI, based on microwave imager, it's available, and combined, these are all swath level products or level 2 products. And resolutions vary from about 5 kilometers all the way to more like a few tens of kilometers, depending on which products you're using. And temporal resolution also varies from about an hour or half hour all the way to about 40 hours. So these are all available in HTF5 format, and they all provide surface rainfall rate, in addition, also provide vertical profiles of hydrometeors that help in deciding latent heating of the atmosphere. This is a summary of GPM Level 3 precipitation products. So Level 3 products are composite products based on Level 2 products. So all these swath data, they are averaged or composited over space and time to provide uniformly graded data. And these data are listed here. iMerge, which is 1/10 degree, and there is almost near polar coverage. And then each sensor level 2 data are combined to give level 3 data, which are uniformly graded. And special resolution and coverage are given in this column. We are going to focus today on iMerge, which is has 30-minute near real time, as well as there is a research quality product also. There is a late product coming out of iMerge. So we will be talking about that and focusing on that for using Python code. So currently they are available at 6-hour latency in near real time, and that will be improving soon. These data, the combined data, are available on monthly and daily resolution. All these data are available in multiple formats, but the native format is HTF5. And a number of tools that we have talked about earlier in session 2 and 3, they can be used to convert these data into netcdf or through OpenDAP, can be saved as ASCII, can have in image forms as well. So this is all possible. Still, the native format is HTF5, and that is what we're trying to work with today. So GPM data user and FTP requests are recorded, and based on that, iMerge is the most requested product, and not surprisingly, because it is uniformly graded at 1/10 degree. Also, it's available every half-hour interval. It combines all the satellite constellations with core, so that has been the most used for applications. Then GMI, which has wider swath, as we saw earlier, that has been used. So level 2 data, which are more popular, are from microwave imager. And then again, brightness, temperature, and radar swath estimates are useful more for research. So this is for application, we are going to focus more on iMerge. So a few updates. This is again PMM site, and this is the home of all the information about GPM and trim also. So data access and updates can be available from this site all the time, and any new research or applications come up, they are always available through this portal. So the GPM products they are constantly improving right now. We had version 3 last year, and then all the constellation satellites were slowly moving to version 4. Similarly, GPROF, which is GMI algorithm, that also switched to version 4 in May. So most of these are now available in version 4. So that's the latest version. Um, Online, you will also find older version data, just if somebody wants to compare or check. But recommendation is that you use the latest version because clearly that is improvement over the previous version. Now, iMerge is still using version 3 because all the constellation and GPROF, they all had to be in version 4 before they all can be merged and processing can be done. So that processing has been going on right now. And in a month or two, version 4 iMerge should be available. So here is the improvement of iMerge that is likely to happen in near future. We have three kinds of iMerge products. There is early product, which is now about 5 hours, but it will become available in about 4 hour latency. Then there is late product, which is 15 hour. That will become 12 hour. And then the final, which is a research quality data, which merges rain gauge data with satellite data. And so that is more of like research quality data, and that has 3 month latency. Uh, but these two can be used for near real-time applications. And there will be value-added products as shown here, like 3 hourly, 1, 3, and 7 days accumulation. Some of them are already available, and they will also be available as geotiffs, so that they can be used with either ArcGIS or QGIS readily. So we will see where these data are available. So currently, again, iMerge is covering 60 south to north latitude, but when the final product comes out in a couple of months, it will be extending from 90 south to 90 north. So as we mentioned, some of the version 4 will be available by hopefully by November of this year. So in late 2007 or early 2018, 17 and 18, version 5 of iMerge will come out. This will be covering entire period starting from 1998 to present. So it covers both trim and GPM era precipitation, and it will have a long time series for climate applications. And this will be available most likely in early 2018. So that is already happening, procedures already going on. And so that all data will be available at half hour 1/10 degree resolution when the version 5 comes out. So again, there's always, because there are multiple satellites used, sometimes if one of the constellation satellites does not report data or there are gaps, then iMerge has to adjust for that. So sometimes there are some disruptions, but usually it is recovered soon. So one of the improvement that's likely to happen is that, of course, with as versions change, products become more accurate. There's detailed documentation are always available online from the PMM site, and iMerge 4, particularly in version 3, it has been noted that at higher end of precipitation, iMerge overestimates precipitation, so there is high bias, but with new version, that should be less so, and the bias should improve at higher end. Also, one of the comments here says that on 8th of September, one of the constellation instruments, SSMIS, was not available. And so that gap has been filled with geostationary infrared data, which are somewhat lower quality, not as accurate as microwave. And so these gaps sometimes affect data quality. When the instruments start reporting data back, then again they are included. If you register to get the data, then you automatically get updates and emails about any data outages or any changes that occur. So from PMM site, there is a way to, through data access, you can get data. Important thing is to register for downloading the data. It just simply requires some information about your background, and it also asks you for your email address, which is your username and password. So these data are completely free. It just requires user registration. But once you register and select appropriate options, you can be informed about any changes that are occurring by email. There are multiple GPM data servers. There are one like J. Simpson is for near real-time data, and all the data are available from Arthur Howe. There are other sites as well, uh, and then there is a site PPS that provides um, precipitation processing system that provides all the data sets from TRIM and GPM. So you can again look at webinar 2 and go through all the tools that are available. There are multiple ways of accessing these data as we saw earlier. Again, all they are listed here. And so FTP, you can download all the data through FTP or use Storm, Mirador, or Giovanni. These are online interactive tools. They let you subset data by for space and time. You can plot data. You can do analysis. There are multiple options available. And again, webinar 2 and 3 would be the place to look for details of these tools. GMI data are also available in near real time through NASA Earth data. Again, these sites do require a registration and login with your email address, but data are completely free. So here also, earlier we talked about Mirador, Giovanni, and PPS Storm, which data products are available through each and in which format they are available, whether they can help visualize and analyze, and what is the way to download data. So new feature between last webinar and now is that PPS Storm is updating registration. Most of you who access data, they must have registered, but now it is updating information. And Mirador, which earlier did not require any registration, is now requiring registration for NASA Earth data. So it's just simple, a few steps that you go through when you first time access, and then you can use it forever. So this is basically, these are the major tools. They allow you to access data in multiple formats. Okay. And Giovanni and PPS Storm also allow map and time series visualization. So in PPS Storm, both level 2 and level 3 data are available. In Mirador also, Giovanni focuses more on level 3 data, and level 2 data will be available soon there, or in near future. But right now, iMerge analysis is available through Giovanni, and it can be plotted in different ways. There are selection of shape files and different regions that you can view through Giovanni. And we have seen that there is a new GPM near real-time SWAT viewer that is available at this site. It shows where core satellite is going, and you can pick from different products. So the idea is to see SWATs or data as they become available. You can constantly watch this. And so this is a new feature that was added between last webinar and this webinar. So just a few words about GPM ground validation. The GPM products are constantly being evolved right now, but there is a GPM ground validation portal that you can access through this site. And there are multiple ways algorithms are tested and data are being validated right now. So there are 4 ways. There is a physical validation going on with distrometers, which measure raindrop sizes. There is polarimetric radar and profiler, and there are aircraft measurements and in situ measurements. They measure cloud properties, microphysical properties to come up with size and shapes and types of hydrometeors in clouds and rain. So they help improve algorithms, especially for radar and radiometer. And then there are also high altitude airborne dual frequency radar and radiometer. They fly on NASA ER2 and DC-8 aircrafts. And these data are collected and then algorithms are validated and updated based on the information. There is also statistical validation going on. You can see the location of ground-based radars. They're shown here. This is mostly over the US. And so GPM TRIM and GPM iMerge, they're all being compared and validated against ground radar data. And so this is a statistical validation that gives idea of biases and random errors or systematic errors in satellite-based products. So you can visit the website to see more information. In addition, a number of field campaigns were planned. The preparation was going on even before, of course, satellite was launched, starting in 2008 and 9. But the major recent field campaigns are listed here, uh, focusing on specific regions such as Olympics that focused on Washington State mountain experiment, and so that's for orography, where there is complex topography, how GPM core rain and snow products can be assessed. That is this. There is also integrated precipitation and hydrologic experiment. This is in Southern Appalachian. Both of these deal with uh, varying terrain precipitation, which was a problem earlier in TRIM. And so that's why these field campaigns were designed and the data are being analyzed. Uh, Earlier two campaigns, Iowa flood studies and GPM cold season precipitation, they were before the launch, but the data have been used to improve algorithms to get GPM products. So right now, as if you go online and search for GPM validation publications, they are mostly about algorithm validation and comparison between TRIM and GPM products. But soon as these data are analyzed and as GPM algorithms are constantly updated after version 4, there will be more concrete ideas about how GPM products are behaving compared to other